Hello you absolute legends, and welcome back to another video of Create Inc. In this video we will talk about the language of 3D printers called GCode and how we can leverage it to get prints that would otherwise be impossible to get. At the end of this video I'd give you a brief tutorial of the tool I created to make it easier to directly generate GCode. If you want to skip right to the tutorial, the timecode is in the description, but if you are interested in getting a deeper understanding of the 3D printing process, please keep watching. At the end of today's video, I would read some of the most wholesome comments I got on my previous video, both here and on Reddit. We are going to talk about a typical 3D printing pipeline, then we would see what GCode is and how a printer interprets it. We would take a very brief look at the full control GCode generator by Dr. Andrew Gliedel, and at the end, we would take a look at my GCode generator, which is very much inspired by the tool from Dr. Gliedel. With that, let's get on with the interesting stuff and move to the explainer table. A typical 3D printing pipeline has 4 different steps. 1. You or someone else creates the model. 2. You export it and load it into a slicer. The slicer would then generate the G-code for you. You take this G-code, you transfer it to a printer of your choice, and happy printing! Today, we are looking to be able to get rid of the first 2 steps and directly generate the G-code. It's not an approach that would work for every type of print, but it's definitely an approach that opens up new avenues for us. Now, G-code isn't something that is specific to 3D printing. It's used in a lot of other RepRap and CNC applications, but 3D printers, and specifically Marlin-based 3D printers, is what we're talking about today. If you aren't familiar with what Marlin is, but you do have a 3D printer, don't worry, whatever we discuss today would almost certainly be applicable to you. To print any shape, there are 2 commands that would form more than 90% of any G-code file. The first one of them being G0. Now this is a very simple command that tells the printer where to go at its maximum possible speed without extruding anything. We need to specify the X, Y and Z coordinates of where we want the nozzle to be, and the printer would simply move the nozzle to that particular point in space. The next command is G1. This command prints a straight line according to the parameters you provide. Just like G0, you need to provide the X, Y and Z coordinates and also the speed at which to travel and the amount of filament to extrude. Now, the E parameter here works differently for different printers. It could either refer to the actual volume or to the length of the filament to extrude. For my particular printer, which is Prusa Mark III's, it's the length of the filament to extrude. And the F parameter here is the speed of the nozzle in millimeters per minute. There are a few other G-code commands that relate to forming shapes, such as the G2 or G3 commands that allow you to create arcs, or the G5 command that allows you to create a Bezier cubic spline. But they are almost never used. I don't know of a slicer that creates G-code with G3 and G5 commands in it. Even if you have to print a circle, it would be formed of many lines which are very minute in length, basically a lot of G1 commands. With enough lines, you can approximate almost any shape. For example, let's take a circle. If I could only make 4 line segments, my best approximation of a circle would look something like this. Now, as I increase the number of line segments or decrease their length, it starts to look more and more like a circle. As a matter of fact, the circle that you saw originally is merely an approximation as well, formed of tiny pixels on your screen. There are different G-code commands for all the different features of your printer, from setting the nozzle temperature to the print bed temperature to setting the fan on or off, and the list goes on. Now we have a basic understanding of how things work. G-code at the end of the day is just a set of commands. But it would be rather difficult to write G-code by hand. It would be nearly impossible to be able to visualize what you want to print. In comes Dr. Gleedle with full control G-code. He came up with this framework that allows you to produce G-code and still be able to control almost everything about it. From print speed to extrusion to fan speed of every individual line put on the bed. I have put the link of it in the description below, and you would find some very amazing prints that he has done that would be downright impossible to do otherwise. When I sat down to create prints using this tool, I realized how well thought out it was. But the platform it was built on, Microsoft Excel, limited what could be done with it. There are a few problems with Excel. Number 1, it's a paid software and not everyone has it. Number 2, since it's based on Excel, it's not easy to put syntactical checks on the commands, which makes debugging really difficult. The third one being to visualize your prints, you have to copy and paste the generated G-code into a slicer of your choice. I decided I would make a tool that is more accessible, and the easiest way to make it reach the maximum number of people would be to put it in the form of a website. There was only one problem. I barely knew any HTML. But I had a few days, so I started from the bottom. I had initially targeted around 10 days to be able to make this, but it took me around 2 weeks of work. It took me 1 week to make the G-code viewer alone. But this right here is the tool in a usable form. It still lacks a lot of features, but it has the basics right. You can type your commands here and your G-code would be generated here, and the resulting model would be shown in this window. Yellow lines for travel moves and white lines for printing moves. Let's take a look at some very simple examples of what we can make with it. Please keep in mind that this is not an in-depth tutorial, it's only a few examples, you can call it a sneak peek, I suppose. If you need more details about how some of the features shown here work, you might need to look into the tutorials of Full Control G-code by Dr. Gleedle himself, because my tool is very much based off of his tool. So let's start with a very simple example. We'd create a square. So for that, I'd create a line Cartesian. The starting point, let's keep it 50, 55, and 0. So when I say Z0, here it means 0.2. because the Z offset is set to 0.2. Then let's say relative to the starting position, which is 50 here, I'd move 50 in the positive direction for the x-axis, nothing for Z, nothing for Y, and nothing for Z. It would be a print move. Let's say the width is 0.2, the height is the width is 0.4, the height is 0.2, both are in mm, and no overrides. Let's go ahead and load it. Here you can see this line has been created that goes from 50-50 to 50-55 to 155. Let's create 3 more lines. We need 3 more edges for our square. So this one, x-axis doesn't change, y goes to positive 50, then x goes to negative 50 and everything else is same, then x doesn't change and y goes to negative 50. Let's reload it. Okay, sorry, I forgot to change the starting positions here, so this should be R0, 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 which means that my nozzle does not move anywhere after this move, so it stays there. Otherwise it's going back to 50-55, 0. It's coming back here. So let's make it R0 everywhere. So here you can see we have our square. So two of the edges are also on the grid of the print bed. So I'd shifted by just a little bit so you can see it better. So here we have our square. It starts from here, which is 55, 55, goes here, then here, then here, and here. So now that our base layer is ready, I would like to do something with this square. I would extrude it out and create it and make a shape out of it, a sort of a 3D model. So I would add a repeat command. So I have to repeat features 1 to 4, these 4. The center, I want it to be in the middle of my square, because everything I do, if I scale it out, I want it to scale it out of the middle. If I rotate it, I want it to rotate around this point. So this point must be, it goes from 55 to 100, which is 55 to 105. So it must be 25 after 55, which is 80, if I'm correct. Yeah. And Y center is also 80. Let's leave angle displacement 0 for the time being. Let's leave radius displacement 0 for the time being. Let's make Z displacement 0.2. Number of repeats, let's make it 80. And the repeat rules feature has not yet been implemented, so let's just delete it and reload our G-code. Here you can see the same 4 commands have been repeated 80 times. Now this is a very boring square. We can turn it into something like a vase or vase, however you pronounce it. Let's add some angle displacement. I'd add an angle displacement of 0.1, which is for every layer it would turn 0.1 degrees counterclockwise. And if I hit reload again, you'd see that there's a sort of a spiral going on here. I can increase the number of layers. Let's make it 400. And there you go. You have made a very simple shape, a very simple geometric design, I suppose. You can see the spiral all around the square shape. You can also add some radial displacement, which would basically increase or decrease the scale of each layer. So again, if you want more in-depth understanding of what polar repeat is, what Cartesian repeat is, you would have to see the tutorials by Dr. Andrew Liedl on the Full Control G-code website. So let's do something like this, and here you can see every layer, it's increasing the scale by 0.2 mm in every direction. So this is a very simple example of a spiral square. All of the examples that I'm going to show you right now, the samples of this code would also be there in the GitHub repository that I would put in the comment section down below. And currently I'm working on a local copy of this website, but by the time this video is out, this website would be live, and I'd put the link of that in the description as well. Let's go ahead and take a look at another example. So this time we are going to create something more complicated. So we're going to use a feature called a line equation. But before I explain to you about line equations, let me explain to you that whenever you're creating a line Cartesian or a line polar, you can only have absolute or relative values here. You cannot have an equation here. You cannot have any sort of a formula here. No expressions are allowed. So when we talk about line equation, you can actually have expressions here. XF, YF, the F denotes formula. So we're going to create a circle. There's another feature called arc or circle. It has not yet been implemented, but you can always create a circle using a line equation. So for this, I'd create a few parameters first. I'd call it, let's say, radius. I want the radius to be 10 seems fine. Then frequency, we talk about what frequency is. Let's keep frequency at 10 as well. So I've created 2 parameters here. So first of all, I'm going to create a circle. This parametric equation of a circle is r cos theta, radius into the x coordinate of the circle would be r cos theta, r cos degrees, and theta would be t-val. I'll explain to you what this t-val is in just a second. Similarly, for our y coordinate, it would be our sine degrees. So please note here, I'm using cos degrees and sine degrees. If you use vanilla sine or cos, they would expect the angle to be in radians. It would still work, but you would have to make sure that the angle is in radians and not in degrees. So I'm keeping the z at 0. My t would start at 0. And let's say we want to create a semicircle, so it would go to 180. So when I say it starts at 0 and goes to 180, this is the value of my t-val. My t-val would start from 0 and it would keep increasing up until 180. By how much? My t-step. So if I give it 1, after each iteration it would increase by 1 degree and it would keep on going until it hits 180. So as long as it's less than 180, it would keep on incrementing. So if I use a value here which is not a factor of 180, let's say 7. So 7 would continue till the 25th iteration, where it would be 7 into 25 is 125, right? 175. And after that, in the next iteration, it would become 182 and then stop. It would not stop at 175. It would stop at 182. So you'd have to keep that in your mind. So it's advisable to always keep the t-step as a factor of whatever this value is. Let's keep the width at 0.4, the height is 0.2. No overrides this time as well. Okay, so but C found where? So this needs to be math.cos degrees and math.sin degrees. So as you can see, I have put in a syntactical check here, so it would tell you of any mistakes that you might make. And there you have it. We have a circle here at 0, 0. So let's shift it to the middle of our print bed, 125 plus 125. I made a mistake. Plus 125. So here you can see in the middle of a print bed we have created a circle which goes from 0 to 180. So with that you can create any arcs as well. If you wanted something that goes from 90 degrees to 180, you can make that as well. You can create a lot of other kinds of features. So in the beginning of this video, you must have seen a Christmas tree like print, which was printing on the air. So for that I used the same thing, a line equation. I'd show you how I did it. So for that I varied the radius of my print as well. So this time we'd create a full circle from 0 to 360. Let's try to modify this circle itself. Let's increase the radius of the circle. Please keep in mind that in these parameters, the value has to be the terminal value. That means you cannot have another value here. Like I cannot keep the value of my radius as frequency into 2. That just won't work. So it has to be an absolute value. Where if you want to enter it into a field that accepts expressions, it can be something like this. An expression would work, but don't reference another variable here or another parameter here. So for radius, I would increase it to 40, so things are easier to see. Let's reload. So now we have a bigger circle here. And here I would vary the radius with a sign of some value. So let's go with, my radius would have to be my base radius plus let's make it absolute, math dot absolute. Now math dot sine degrees of t-val into frequency. I'm I'm sure I made some mistake here. And magnitude, I should multiply it by the magnitude. Let's make this a parameter as well. Let's make magnitude a parameter. Somehow everything is ending up to be 10 here, but it's fine. Yeah, I made some mistake somewhere. Missed a tilde here. Added a tilde here. Let me just check the brackets real quick. This one is fine. This one is fine. This one is fine. Yeah, so here you can see we have something very wobbly. The same thing I would do to the radius of my y parameter. Let's go here. And there you go. You have a flower shaped design, so to speak. So you can mix and match all of these different features. The samples, as I told you already, you'd find them in the GitHub repository, and the link is in the description below. I have done a few slightly more complex things when I created that Christmas tree print. You would find the exact code in the GitHub repository, don't worry about it. And you can just, once you're done making anything, if you want to print it, you can copy the G code from here, Control A, Control C, or since I'm on a Mac, Command A, Command C. I want to implement a export and load design feature which has not yet been implemented. So as you can see, this is clearly a tool in its infancy, and not making any excuses, but it was made in just 2 weeks and I did not know any HTML at all. I did know some JavaScript though. Before we end this tutorial, I'd like to show you a few codes for the prints that I did. You must have seen the Christmas tree print in the beginning. I would just copy and paste it right now. And if designs are very complicated, it might take a second for your browser to load it. It might even crash. It might say this website is unresponsive. But if you keep clicking wait, it would eventually show you the results. So this is the code for the Christmas tree print that you must have seen in the video in the beginning. We can check each line. We can see how it's built, one on top of the other. So here I'm adding some custom G code as well. This is for filament change. So because I wanted it to be a multicolor print, and this right here must be, this is for the nozzle temperature, and this one is for the fan speed. I switched the fan on after the first few layers. So yeah, that's pretty much it for this tool, and I hope you like it, and I hope you have a lot of fun using it yourself. Now it's time to look at some of the comments from my previous video. Right off the bat, I would like to acknowledge a comment from Pattern to Print. For anyone who wants a more in-depth explanation, you can see it here. I confirmed with him, and he is actually the creator of the technique I used in my previous video. Glad I got a comment from him. If you haven't seen my previous video, I'd put the link of it in the description. I'd put a card somewhere here, or I'd put it at the end of this video. For my next comment, Necrochronicus says, everyone using a 3D printer at all is standing on the shoulders of giants. It's all about what you can actually make with it. In the next comment, Darklight says, I find it hilarious the efforts we go to 3D print 2D objects. CPU Banana says, love the editing used to explain how it all works on the table. And lastly, my favorite comment that kept me going for the next video was from Valentine Rodriguez. I hope you continue this channel. It is very entertaining. Thank you, Valentine. Thank you to you personally for keeping me going. So with that, we're nearing the end of another video. I actually had a chance to talk with Dr. Gleedle on Reddit, and at the end of this month, I would like to get in touch with him again and discuss the future of our G-code generators. And that brings us to the end of this video. If you liked it, you know what to do. If you didn't, the other one works fine. If you have any inputs at all, leave them in the comment section down below. Hit subscribe for more such content, and until next time, just keep building.